Hello everyone, good evening. My name is Ashwini Gupta and today we are going to discuss about one of the most important topic of class 9 CBSE physics, that is called conservation of momentum. So without any delay, let's move to our screen and we will be discussing about the law of conservation of momentum. But if you are the first one, so please subscribe the channel, share and like our video and do comment in the comment section. So let's move to the law of conservation of momentum. See, momentum, as we know, that the product of the mass and velocity, that is called momentum, right? So whenever we are talking about this law of conservation of momentum means that the momentum will be remain same, राइट। कहने का मतलब क्या है अपन का मतलब है कि अगर किसी बॉडी के मोमेंट बात करें, सिस्टम की बात करें, तो ये जो लॉ कहता है, तो ये कहता है कि भाई जो टोटल मोमेंटम होता है, अगर हम बाहर से कोई एक्सटर्नल फोर्स नहीं लगाते हैं तो ये मोमेंट कांस्टेंट होता है। किसी भी सिस्टम का मोमेंटम वेरी नहीं करेगा किसी भी इवेंट के पहले या किसी भी इवेंट के बाद। Event means some of the things like collision is there and all. So we will be discussing in detail about that. So first of all, let's try to understand the concept, the statement that the total momentum of the system remains constant, or we can say the total momentum of a system before an event will be equal to the total momentum of the system after that event, right? So this is the law of conservation of momentum. आप फिजिक्स में 3-4 कंजर्वेशन ऑफ के लॉ पढ़ोगे, लाइक कंजर्वेशन ऑफ चार्ज, लाइक कंजर्वेशन ऑफ एनर्जी, कंजर्वेशन ऑफ मास, राइट। सो द इन द सेम मैनर वी आर हैविंग दिस लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम। ठीक है, तो यहाँ तक मुझे लगता है कोई समस्या नहीं होनी चाहिए। इसका सीधा सीधा आप मतलब निकाल सकते हैं कि किसी भी सिस्टम का जो टोटल मोमेंटम होता है वो कंजर्व होता है, वो कांस्टेंट होता है अगर हम एक्सटर्नल फोर्स अप्लाई नहीं करते हैं। That means this law will be hold only when if no external force is being applied on that system. ओके, एक चीज और यहाँ पे ध्यान देने वाली बात होगी, ये जो सिस्टम की हमने बात करी है, ये सिस्टम क्या होता है, तो बेसिकली ये सिस्टम जो है इट इज अ ग्रुप ऑफ डिफरेंट बॉडीज। कई सारी बॉडीज मिलके एक सिस्टम डेवलप करती है, राइट। जैसे अगर हम बायोलॉजी में बात करें तो वहाँ पर हमारे बॉडी में कई सारे सिस्टम है, ऑर्गन सिस्टम है जो मिलकर पूरी ह्यूमन बॉडी का क्रिएशन डेवलप करते हैं। इसी तरीके से किसी भी सिस्टम में कई सारे कंपोनेंट्स हो सकते हैं, कई सारे बॉडीज हो सकते हैं। ठीक है, चलिए, तो ये तो होगी लॉ की बात। अब हम इस लॉ को डेराइव करते हैं कि इस एक एग्जाम्पल के थ्रू हम इसको वेरीफाई करते हैं। ठीक है, तो ये एग्जाम्पल मेरे पास है, ये यहाँ पर मैंने एजम्पशंस क्या माने हैं, लेट अस सी। There are two bodies A and body B having different masses MA and MB, right? So what are the assumptions we are having? The assumptions we are having is the two different bodies of masses M1 and M2. So A body has the mass of M1 and B body has the mass of M2. At the same time, if I say, so the first body is having the initial velocity UA, which is considered more than the initial velocity of second body, that is UB. That means one assumption we have also made that UA will be greater than UB. In that case, we can say that the body A will be going to collide with body B. So this is the first situation, that is before the collision, right? So if I say the total momentum of system before collision, so you will be getting, it will be MA into UA plus MB into UB, because in this system we are having two bodies having different velocities UA and UB, so the momentum will be like this. Now since as I have told you that the initial velocity of the first body is more than the initial velocity of the second body, so it's a time when they are going to collide. So when they are going to collide, so they will be having different forces like FAB, the force caused by A on B, and as a reaction the FBA, the force reaction force caused by body B on A. And after this collision, whenever see it's a very small time, that is t, for which they are stick together colliding. After that they will be split, and you see after this event, after the event of collision, the bodies are gaining the velocities va and vb. So if I say the total momentum after collision, the total momentum after collision, so we will be having ma va plus mb vb, right? So whatever the law we have seen, that law says that, what that law says, that it says that ma ua plus mb ub must be equal to ma va plus mb vb. So this thing the law of conservation says, and we have to derive this one, right? So let's start deriving this one. So about this, I'm just clearing all the things here is on the screen. Now, how can we derive that one? So let us see. If I say in the following figure, this is the before collision, this is the after collision. So if I say according to the second law of motion, according to second law of motion, as we know, the rate of change in momentum is equal to the applied force, right? So this is the applied forces that are being developed, right? So first of all, let us try to find out the change in momentum. So change in momentum of body A. So for body A, if we're talking about, so change in momentum will be basically final momentum minus initial momentum, right? Yes, initial momentum. That means, see, if we are talking about the final momentum of A, so it is going to be MA into VA. That is MA into VA minus initial momentum MA into UA. Now, we can add one thing, that is rate of change in momentum. Rate of change in momentum. So when we have included the rate term, that means it's a time for which the body was colliding. So momentum of body A, so it will be ma va minus ma ua over time t, right? And if you are not wrong, if you recall, this rate of change in momentum is basically the force, right? It will be the force. So what does it mean? During the collision, the force exerted by body A on B, that is FAB. So basically this is going to be FAB. So I'm pointing this equation number 1, right? Now, similarly, I'm just changing my color of pen. Similarly, we can have the rate of change in momentum of body B, right? So it will be FBA, because we are talking about the body B. So it will be, now the final momentum for the body B will be MB into VB minus initial momentum will be MB into UB, as for A was, over the time, that is same, that is T. Equation number 2, right? So what we have got, these two statements we have got by the second law of motion, that whatever the rate of change in momentum is, that will be the force. Okay, now coming to the next slide. And if I say, and I'm just pointing the image here for you all, that is the image. Wait a moment. Okay, no issue. So let's move ahead to another page. See, so what we have seen here, we have seen that FAB, that is equal to MAVA minus MB. Sorry, it is not MB basically, it is MAUA over time T, and similarly FBA is equal to MBVB minus MBUB over time T. Okay, now here we have to point out one thing that is very important, that is from third law of motion. What the third law of motion says, my dear? The third law of motion says FAB will be equal to minus FBA, right? So keeping this in mind, we can write here MA VA minus MA UA over time T is equal to MB VB minus MB UB over time T with a minus sign, right? Now T and T will be cancelled out, so we will be getting here MA VA minus MA UA will be equal to MB VB minus MB UB, and when this minus is being introduced, it will be minus and it will be plus, right? So again, doing reshuffling, and after reshuffling, what will be, we will be getting, taking the V component one side and U component another side. So we can say that this U component will be toward this one and V component will be this one. So we will be getting MA VA plus MB VB is equal to MA UA plus MB UB. Now this is the required equation. If I say here, you can see very clearly that what we can see. We can see that this is the total momentum of the system after collision. This is momentum after collision, and this is momentum before collision, right? Got it? So we can simply say, hence from this one we can conclude that the total momentum remains constant. Hence we can say the total momentum will be conserved. That's it. So this was the concept of law of conservation of momentum. We have seen that how the momentum is being conserved of the system if no external force is being applied. I hope this whole video, this way of representation you have understood. If you like the video, if you love the video, please and please subscribe and share the channel. Thank you very much. By this आई वुड लाइक टू टेक लीव. मुझे लगता है कि ये चीज़ अब आपको समझ में आ गई होंगी कि कैसे अगर हम कोई फोर्स अप्लाई नहीं करते हैं तो मोमेंटम कंजर्व होता है। ठीक है मेरे प्यारे बच्चों, अगर ये चीजें आपको समझ में आई हो तो कमेंट सेक्शन भर जाने चाहिए और चैनल को ज्यादा से ज्यादा संख्या में सब्सक्राइब करें, शेयर करें। थैंक यू वेरी मच, बाय बाय।